So this time we're talking about a numerical method which is called Newton Raphson. So the Newton in question is Sir Isaac Newton. The Raphson is a guy called Joseph Raphson. I'm not sure if he collaborated with Newton or whether they were working on the same thing at roughly the same time and both were credited with this process. But anyway, here we go. Okay, so here's Barbara trying to use Newton Raphson to find the largest root. Well, the largest root is that one there, and we're told that that's somewhere between x equals 2 and x equals 3. So the way that Newton Raphson process works is to choose an initial value, find the point on the curve, and then take the tangent from that point and see where the tangent crosses the x-axis, and that gives us a new approximation. So clearly that value that I've just chosen there would lead to an approximation which would be better and get closer to the root 2. So any value to the right of the root would converge on the root. In fact, values of x greater than, or to the right of, if you like, the turning point would converge on that root as well. And there are some points here where if you took the tangent from there, they would home in on that largest root as well. But to be safe, any value of x greater than 1.9 would converge on the largest root. If you chose the value of -2, visually, just looking at that diagram, then that would also be a value that would converge on the largest root. But 0 might not. If you chose a value of 0, that would probably converge on the second root there, that one. So let's look at an initial value of x which initial value x that should be avoided. And that is the place where, if we chose here that value there at the turning point, then the gradient at that point is 0. So the tangent at that point would not cut the x-axis at all. As far as Newton Raphson is concerned, it would be invalid because we'd be dividing by 0. So we should certainly avoid x equals 1.9, where the turning point is. Also, she should also avoid using -3.1 as well. Okay. Let's look at the final part of the question now, the initial value of x that would converge on the negative root. That's this negative root here. So if we chose a value of x equals -6, then the tangent would converge on the negative root. If we chose a value of -4, then the tangent would again converge on the negative root. In fact, any value of x which is to the left of the turning point here would converge on the negative root. So any initial value of x smaller than -3.1, which is where the negative turning point is, would converge on the negative root. So there we are, good old Newton Raphson.